All right, welcome. If you are experiencing any audio issues with your device, you can use the call-in number, which I'll put in the chat in a minute. Today's presentation is being recorded and will be available within 24 hours on the ARM DevSummit site. We welcome your comments and questions for the speakers. Type any of your questions into the chat box at any point during the workshop, and please send your chats to everyone and not just the hosts. If you have any questions about our code of conduct, please see the FAQs on the ARM DevSummit site. And if for some reason the Zoom meeting ends prematurely, please try the link again from the ARM DevSummit right away or from your email that I sent. And if that doesn't work, then just give us another 10 minutes to put up a new link, which we would email to you. And then I will hand it off to Arthur.
Hi, folks. So I'm going to be your guest for that workshop. We are going to start with a quick presentation where I'm going to introduce the Graviton2 processors, and then we'll switch to the labs, and I'm going to give you access to the instructions and the lab environment. I know that there are a couple people in the audience who registered late, so I'm going to get their email and I'm going to send them the hash codes to access the lab environment. I'll do that as soon as I will be done with the presentation, so that the other are going to be able to start going through the labs. The labs are self-paced, so you should be able to run them on your own. And of course, if there's any questions during the lab, I'm there to answer. I can take control over your accounts if needed, so it should be right for everybody. Okay, on that, I'm going to share my screen. Okay, so you should now be able to see my screen. Oh, not yet. That should be the case now. Excellent. I'm just trying to be back in a mode where I would have access to the chat. Where is that one? Okay, I got it. So let's get started. So you probably know that AWS has one of the broadest and deepest compute platform. We have today more than almost 300 different instance type designed for many different workloads. We are trying to cover as much as possible any customer need. And we started our journey in the cloud with instances that were mainly using Intel-based processors. We later introduced AMD-based processor. They were offering an interesting combination between performance and price. And our last addition to that pretty large family has been the AWS designed Graviton processor based on the ARM architecture. So the Graviton processors are custom AWS silicon that we designed based on the ARM Neoverse cores, the Neoverse N1 for the Graviton2 processors. And we've been designing and optimizing them specifically for cloud native workloads. The reason why we have chosen to start designing and building our own processors is that because it gives us the full control on the value chain, and we can iterate fast and control the entire platform that we are bringing to our customers, which allows us to provide you with better performance and lower cost. We have released 2 generations of ARM-based processors. Back in 2018, we introduced our first Graviton generation, which was the first time where we would make available an ARM64 processor on AWS. We made it a first-class citizen on the EC2 platform, but that was a bit of a niche offering, not a super powerful one, but pretty good still for some scale-out web workload. Actually, it was a repurposed version of an internal chip that we were using for our Nitro virtualization platform that we put into a server to bring that first ARM64 platform on our cloud. The Graviton2 processor, we introduced it last year at reInvent, is a completely different beast. That's the first time where we started from a blank sheet to build a server processor. So we packed 4 times the number of CPUs that we had in the first generation in that one, so 64 cores. Overall, it brings 7 times more CPU performance, and on a per physical core basis, it's twice faster than the previous generation. From a manufacturing standpoint, it's also a more modern manufacturing technology, 7 nanometer instead of the 16 that we had on the previous generation. And it's a way bigger chip compared to the previous one, 30 billion transistors instead of the 5 billions we had in the first generation. Those processors are available in 4 different instance families. So we have the M6G, the C6G, and the R6G, which are our general purpose instances with more or less memory. The M6G is the mid-range, has 4 GB of memory per physical core. The C6G has 2 GB and the R6G has 8. So depending on the workload, you might choose one or another. And we very recently introduced this T4G, which is a burstable instance type that is well suited for any workload that would be quite spiky and usually using a small amount of CPU. So anything that would in general run at 20% CPU, something like that, and would spike from time to time is a good candidate for the T4 family. Overall, they tend to offer a significantly better performance than their Intel counterpart, and we priced them 20% cheaper. So we tend to say that from a price performance standpoint, they can be up to 40% better. Your mileage will vary, depends on the workload. We've seen customers who found them to be way faster than that, so the price performance ratio was even better, and at least you're going to get the 20% cheaper prices. They're already available in many regions, and for those who are wondering, we will keep on adding those instance families to more regions. And they come in many different sizes, including a metal version. The metal version is one where we remove the virtualization layer. You get access to the entire system, which is pretty convenient when you're doing low-level profiling or anything that would require to access all of the hardware performance counters. Just checking at the chat. Okay. From a software standpoint, those instances are available under Linux right now. There's not yet any commercial version of Windows Server available for the ARM64 platform. We are eagerly waiting for that. On Linux, the ARM64 architecture is a first-class citizen since many years already. So all the major Linux distributions do support the Graviton2-based instances. Amazon Linux, obviously, we take great care to ensure that it is optimized for the Graviton2-based instances, but Ubuntu has done the same. SUSE is supported also. Red Hat starting with the 8.2 version is pretty well supported. And you can even run FreeBSD or NetBSD, which is an interesting thing because it shows that those instances are built in a way that they are following the standards, so any operating system can easily be ported to those. From a container standpoint, the ARM64 architecture is well supported also, and we have added support for our Graviton2-based instances to all our container orchestration environment, so ECS, EKS, and we added support for multi-arch containers in ECR. We will see that in one of the labs. Firecracker, which is our micro VM environment, supports the ARM64 architecture. And we recently released Bottle Rocket, which is an open source project led by Amazon that brings a Linux distribution targeted at running container-based workload. From a tooling perspective, most of the AWS tools are obviously available for the Graviton2-based instances. And I want to highlight Amazon Corretto, which is the Amazon long-term supported version of OpenGDK. We are strongly involved in the OpenGDK community. So we commit patches to improve the performance on the ARM64 architecture, and we will support that in the long term. If you want to get more details, tips and tricks on how to port your applications to the Graviton2-based instances, we have assembled a getting started guide that you can find on GitHub. We are listing there some tips and tricks on what are the best compiler options for the Graviton2-based instances, details about which versions of the different languages or runtimes are going to give you the best performance, that kind of stuff. And we keep adding more when we either optimize something or when we find something that could be useful for our customers. As a summary, so you now have access to 4 different instance families powered by the Graviton2 processors. They offer a better price-performance ratio than any existing instances in our portfolio. You can apply them to a very broad spectrum of workloads. More or less any application that can run on ARM64 is a good candidate for those instances. The Linux distribution are perfectly supporting them, and any open source based workload is a perfect candidate. They're all available now in many regions and even as bare metal options. Now, unless you have any question, we will move to the workshop part of that session. So you will be accessing, and that's probably what you've seen in the emails that I sent you today, you will be accessing our lab platform through this URL. So Event and Join is the tool that we use to distribute accounts for attendees running those workshops. I'm going to switch this slide, but there will be a last slide with that URL and the URL to the instructions. When you will connect to this dashboard, it's going to ask you for a hash code. I sent you all a hash code by email. I hope that you have all received it. If not, please let me know in the chat. And yes, the slides will be available, or if they are, I don't know how they will be redistributed by the ARM team, but if you don't get them, please send me an email and I will send you. You probably got my email when I sent you the hash code this morning. So you're going to enter the hash code on that page, and that's going to bring you to your team dashboard. You can set your team name. That's going to help me finding your account in case you would have any issue while running the workshop. Once you've done that, there's a link to the AWS console. That's the one that you will use to open the web management console. it's going to guide you to that page. And when you click that link, you will reach the console. The dashboard link is there. Below there's the link to the instructions for the workshop. I'm going to pass that link to the chat too, so that you won't have to type that entirely. Just let me find out how I can send that to everyone, and you will have that in a second.
I can go ahead and email it to everybody.
That's done. So the link is in the chat now. Let me know if you have any trouble accessing the instructions. I can put the instructions on the shared screen. So the instructions look like that. There's a getting started where you will be guided through some initial activities. You will be setting up a Cloud9 environment. This is by no way mandatory, but it avoids having to install the AWS environment on your system. And it has proven during workshop to be way easier than expecting people to install the AWS CLI on their laptop. So please go through that. And then there's a first lab that will guide you through installing Corretto on an instance and running a small Java-based workload with Tomcat. The second lab will guide you through the migration of an existing simple Go web application to ARM64, and you will learn to build a dual arch Docker container along the way and deploy that and check that it runs correctly. And optionally, because given the time we have, I'm not sure that everybody will go through the free labs. The last one will guide you to use code build, which is one of the build system available on AWS, to build natively an ARM binary on a Graviton2-based instance and test that binary on a Graviton2-based instance. Now it's time for you to go hands-on. If you have any question, I'm there. You can either ask it directly or type it in the chat. I will be monitoring the chat, and I'm going to be there for the next 2 hours. Any questions so far?
Okay, Ziad, so I'm following you now.
Yeah, so I know that you're the one that is missing a hash code. I'm just sending it to you right now. Give me a couple seconds to get it and send you.
Yep, I can hear you.
You received the code?
Yes, I can. Um,
Okay, I hope everything is going well for everybody. I'm giving some tips and tricks to some that are encountering some issues, but so far seems to go well. If you have any question, don't hesitate to send it to me in the chat, or if you have any question that you think could be helping everybody, send it to everybody.
I ran into some issues and had to redo some of the steps. Apparently there was an issue with
Sorry, I'm not sure who was speaking.
sorry, it was me. I was speaking in the wrong window.
Okay. No worry.
Okay, lab 2. Okay, this is the Docker magic that I never managed to understand.
So yeah, to answer Martin, Perf is supposed to be there on Amazon Linux too. So Amazon Linux 2 is based on Red Hat 7, loosely based, I would say, because we update the kernel more regularly and a couple other pieces. But still, it's based on that now older and older design. So there are versions that are still lagging behind. GCC 7 is definitely not the version of GCC from which you would expect the best performance on ARM64. So switching to GCC 10 is definitely helping. We mentioned that on the Getting Started guide. I'm gonna pass the Getting Started guide link to the chat, by the way, for the ones could join later. Let me do that. So here it is. And yes, Perf is supposed to be there on Amazon Linux too. I think I remember using it a couple weeks ago. We had a bug initially when we released the first generation of the Graviton instances, but now it should be there. And also in Amazon Linux Extras on Amazon Linux 2, there's a more recent version of the kernel, 5.3, I think we put now, that is called kernel NG for next generation. So if you want to experiment with a kernel that would be more recent than the one shipped by default, there's always that option. Okay, I had not noticed that we are past the time that that workshop was supposed to last. What I can propose, so I hope you enjoyed. I'm going to leave the lab environment open for the one who want to spend some more time on it, if you want to spend more time. The instructions are going to stay published for a while. If you try to reproduce those instructions on your own account, just be aware that Lab 2 is not going to work. It relies on an AIM profile to be created in your account. If you want to reproduce that at home, please just send me an email, the email from which you received the hash code, and I'm going to send you a CloudFormation template that would create that role. If you have any question in the future about the Graviton2-based instances, you can definitely reach out directly to me. I'm going to send Eva, who was our facilitator during that workshop. Thank you, Eva, by the way. I'm going to send her a summary with a couple links to instructions and documentation about the Graviton2-based instances. And again, if you have any question or need any assistance, or if you want to set up a similar session in your company, or set up a specific Graviton session in which we could present the Graviton2-based instances and answer any technical question that you might have, just drop me an email and we would be happy to organize that. metrics, I'm seeing the question from Martin. I guess the metrics question are about perf. On the T4G instances, if you are to use perf, that's right, you will see very few metrics, and particularly not the interesting ones such as the cache misses or the number of instructions that you're returning, that kind of stuff. If you want to do any low-level profiling like that, either use the largest instance size in the family and choose anything but the T4G instances. T4G is a little bit of a specific family, so we don't give access to the hardware performance counters on those instances. Use a 16x large in either C6G, M6G, or R6G. You will get a first level of performance counters. And if you really want to access everything, use a metal version. On the metal version, we remove the virtualization layer. So you have direct access to the bare metal system. Thanks to the Nitro system, there is still a level of isolation that we manage at the border of the system because we emulate the devices on the PCI Express bus. So the network device that you see are actually emulated from external cards that are also running on ARM processors, by the way. But on those metal instances, you will get access to all the performance counters. So anything where you would need to do performance analysis or things like that, those metal instances are pretty convenient. If you test on metal instances, maybe something that will be surprising at the first launch is that they take a lot longer to boot compared to the virtualized one. The reason for that is that we do many checks at the firmware level when we start those instances to ensure that the firmwares have not been tampered by anything or things like that. So it takes up to 6 or 7 minutes to launch a metal instance compared to the 30 seconds or so that it takes to launch any virtualized instance. Okay, on that, thanks a lot. Thanks a lot for attending. I'm gonna close my shared window. I'm gonna leave the chat, but if you wanna keep on running the workshop, the instructions are there, and I'm gonna keep the lab environment open for the next hour or so, and then I will shut down that environment, and you will be logged out of those lab accounts, and those accounts will be removed. Thanks a lot again, and have a nice day.
Thank you, Arthur, for this workshop.
You're welcome. Have a nice day.
Thanks.